Hey guys, today we are just going to do a quick review on factoring. We are going to be using factoring quite a bit this year in secondary 3, so we want to make sure we are good at it now before moving on. So that being said, if any of you still feel uncomfortable with factoring at the end of this video and then after doing your homework, let me know because we really do need to get good at it before moving on. So just email me if you do need more help. So factoring is the reverse of multiplication. So when you factor a polynomial to find its equivalent expression, it's going to be a product of two smaller polynomials. So an equivalent of that is called a factorization. So you'll see that terminology as well as saying find the factor or find the factorization. So we're going to start off with the basics first, and that is finding the greatest common factor, the GCF. You'll see it written a lot. When factoring a polynomial, we look for factors in common to every term. And then we also, when the leading coefficient is a negative, we don't like that to be negative, so usually we'll factor that negative number out as a part of the greatest common factor. So here's a few examples. We want to find the common factor. If I look at these two terms, we have a negative 4x squared. I know that little 2 is kind of small. And then a minus 16x. First off, I just want to note that the leading coefficient, which is this negative 4, is negative. So like I said up here, when it's a negative number, we don't like this first term to be negative. So I know when I take my greatest common factor out, my GCF, I'm going to take a negative because I don't want this term to be negative. And then if I look at the two numbers, 4 and 16, I want to find the biggest number that goes into both numbers. So 2 goes into 4 and 2 goes into 16, but it's not the biggest one. 4 is going to go into 4 and 4 is going to go into 16. So 4 will be the greatest one. So we want the biggest number. And then if I look at the x's, x squared really means x times x. You can even write it out if you want. And then this one has 1x on it. So I can take 1x from both of them as part of my greatest common factor. So my GCF here is negative 4x. And some problems will just say, what is the greatest common factor? And they just want you to state it and you would be done. But if they say to factor out the common factor, that means they want you to actually factor it out front, where you're going to write your greatest common factor and then write what's left over on the inside of the parentheses. So I found my greatest common factor. It's a negative 4x, and we write that out in the front. And then to get the inside, however many terms you started with is how many you're going to end with. So I'm going to have 2 terms on the inside of this. What you're essentially doing is you're dividing. So if I have my negative 4x squared and I divide it by a negative 4x, well, the negative 4's cancel, and then x squared, remember that's the same as x times x, one of the x's is going to cancel. So I have 1x left over. So that's going to go on the inside here. And then same with negative 16x. If I divide that by negative 4x, the negatives here are going to cancel. And then 16, when I divide it by 4, has a 4 left over. And then x is just going to cancel out with the x. So the only thing left over here is a 4. But note that the negatives did cancel. So instead of having a minus sign here, it's now going to turn to a plus sign. So we're going to have a plus 4 since this turned positive. And so when they say to factor out the common factor, this is how they want you to write it, with the GCF in front and then the remainder part on the inside. Okay, let's try another one. Here we have 9m squared minus 27. And I know that little square is really small. So when I'm finding my greatest common factor, I like to look at the numbers first. So 9 and 27. 3 goes into both, but again, I want the greatest one, the biggest one. So 9 will go into 9, and 9 also goes into 27. So 9 is going to be our common factor. And this leading coefficient, 9, is already positive, so we don't need to take a negative out. We want this one to stay positive. And then after I look at the numbers, I look at the variables. But this one has an m squared, but this one doesn't. So I can't take any m's away if this one doesn't have any to give up. So our greatest common factor is just a 9 here. So if I want to write out the actual answer, I'm going to put the 9 in the front, and then whatever is left over on the inside. So since I started with 2, I'm going to end with 2. So 9m squared, if I divide it by 9, the 9's cancel, and I'm just left with an m squared. So that's going to go on the first spot. And then we had our 27, and it was a minus 27, so we can bring that negative with. And if we divide that by 9, negative 27 divided by 9 is negative 3. So we're going to have a minus 3 on the inside. And then that would be our answer. So again, just look for the wording. They might say, what is the greatest common factor? And you would just put this part. If they say to factor out the common factor, they want the entire answer. Okay, the next one looks really scary, but I promise it's not that bad if you just break it down step by step. So again, when I see multiple terms like this, also with multiple variables, I like to just break it down into pieces. So I do the numbers first. So if I look at 25, 35, and negative 15, I want the biggest number that goes into all 3 of these. So 25, 35, and 15, I know a 5 can go into. So my greatest common factor is going to have a 5 in it. Now I look at just one variable at a time. So if I look at the x's, and this is kind of small, maybe I'll write it bigger. We have an x squared, an x to the 6th on this one, and an x cubed. So that means this one only has 2 x's to give up, while this one has 6 x's and this one has 3 x's. I can't take away 3 or 6 x's from this one if it only has 2. So kind of your rule when it comes to variables is you're going to take the smaller amount. I can take 2 away from all 3 of these, but I can't take 3 away or 6 away from this little one. So I can take 2 x's away from each one. And then the y's, I'll write them bigger again. We have a y to the 5 here. This one is a y cubed, and this one is a y to the 4th. So again, this one has 5 and this one has 4, but I can't take 5 or 4 y's away if this one only has 3. So we take the smallest amount, which is y cubed. So that's our GCF on this one. And then if they actually ask you to factor it out, you're going to write that GCF in the front, 5x squared, y cubed. And then your answer, or the remainder part, is going to go in here. And we had 1, 2, 3 terms to start. So we have 1, 2, 3 to finish it. So again, it's like dividing. If I take that first term, 25x squared, y to the 5th, and I divide it by 5x squared, y to the 3rd. Let's just do one part at a time. With our numbers, 25 divided by 5 is 5. X squared divided by x squared, since these match, they just totally cancel and there's no x's left. But then on this one, we have y to the 5th over y to the cubed, so they don't exactly match. So when you have a scenario like this with the same variable and they're being divided, you're going to subtract the exponents. So I'm going to do 5 subtract 3, which is 2. So I'm going to have a y squared. And remember, the x's just went away. We don't have any. So our first term is 5y squared. Now let's do the second term. We have 35x to the 6th y cubed, and we're dividing it by 5x squared y to the 3rd, just that greatest common factor again. So again, I just do the numbers, then the x's, then the y's. So 35, if I divide it by 5, is 7. X to the 6th divided by x squared. Remember, we're going to subtract those exponents. So 6 subtract 2 is 4. And then look at the y's, they match. So, and you can kind of think about it as 3 subtract 3 is 0. So we don't have any y's left over. So we just have a 7x to the 4th. And since that was a positive number, this is going to be a plus sign here. And then our last one, I'm kind of running out of space, but we're taking the negative, don't forget that minus sign here, a negative 15 x cubed y to the fourth. See if I can squish it on here. Negative 15 x cubed y to the fourth. And we're dividing it by 5x squared y cubed. So just the numbers, one step at a time. Negative 15 divided by 5 is negative 3. So we're done with that. X cubed divided by x squared, we're going to subtract the exponents. So 3 subtract 2 is 1. So we'd have x to the 1, but we usually don't write our powers of 1. And then with our y's, we have y to the fourth over y cubed. So again, 4 subtract 3 is 1. So we have y to the power of 1 again. So negative 3xy. And since it was a negative, it will be a minus 3xy. And there's your answer. So I know ones like that can be really intimidating and overwhelming. You're not going to have them very often. And like on the ACT, you probably wouldn't see one like this because it is kind of time consuming. So just my tip for these kind are just break it down as much as possible. So do your numbers in one step, the x's in one step, the y's in one step. And that just helps kind of break down all the pieces so you don't have all of this to do in one big step. Okay, so that's greatest common factors. The next thing we're going to review is factor by grouping. I know there's different ways of factoring. I've taught different ways in my teaching career, but I found that if you just teach one way for all of them, it's usually easier for kids to remember. If you learned in your other math classes how to factor in a different way and you're comfortable with that, great, go for it. I'm just going to focus on this method though, which is factor by grouping. So when you factor by grouping, when you do factor by grouping, here are the steps you're going to do. First, you want to make sure to that if there are any common factors that they've been taken out. That's your greatest common factor. That's always going to be the first step, no matter what method you do. If there's a greatest common factor, you want to take it out. And that actually will make the problem easier for you. So it's a step worth doing. Step 2 is you're going to multiply the leading coefficient A and C. This is for doing a trinomial. We use this little format, ax squared plus bx plus c, whenever we use trinomials, where these letters A, B, and C are going to just be your numbers. So step 2 is you're going to take that first number A and that last number C, and you're going to times them together. So you're going to do A times C. And then when you do that, you're going to look and see what numbers multiply to be this, but add to be that middle number, B. And then once you have that, you're going to rewrite your middle term using those numbers instead. And that's how you start with factor by grouping. So I know just reading the steps can be not that helpful. So for me, it's a lot more helpful to actually see it written out. So we're going to do that first. So I have a few different problems here for you. When you do the factor by grouping method, the nice thing about it is it will work if you have 4 terms or 3 terms. You don't need to learn more than one method for the different terms. So that's why I like to do this one. I actually think that 4 terms are easier than 3 terms. You would think maybe it would be the other way around because you have more things going on here. But 4 terms is actually easier. So let's start with a 4-term problem. And the reason, again, I like to do 4 terms is because when we're doing factor by grouping, the main idea behind it is you're going to be putting things into groups of 2. So since there's 4 terms already, it's really easy to just make 2 groups of 2, since 4 is an even number. So when you do that, I just put parentheses around the first 2 and parentheses around the second 2. Make sure to bring any negatives in if you need to. But once you have these groups, you're just going to look at each one individually. So I'm going to take the 3x minus 3y, and we're going to find the greatest common factor for it, which we just practiced doing. So for 3x and 3y, the only thing they have in common is a 3. So that 3 is my greatest common factor that's going to go out front. And then the inside, since I started with 2 terms, again, I need to end with 2 terms. We're just going to get that by dividing each of these by 3. So 3x, if I divide it by 3, the 3's are going to cancel and I'm just going to be left with an x. For negative 3y, if I divide it by 3, the 3's cancel, but I still have that negative. So I'm going to be left with a negative and a y. So that's my first group. Once you've taken the greatest common factor out of the first group, you're going to move to the second one. So we had a negative ax plus ay. I know it's kind of weird having those a's in there, but don't worry about it. We're still doing the same idea. I want to take the common factor out. So because this is considered our leading term in this one, it's negative. We don't like that to be negative. So we're going to take a negative out. And if I look at the two parts, they both have an a, and that's all I can take out. So we're taking out a negative a. If I take a negative a away from negative ax, the negative a's cancel, and we're just left with an x. So that's going to go on the inside. But here, I have ay. I'll write this part out. If I divide it by a negative a, the a's cancel, but the negative doesn't. So I need to keep that negative along with the y. So I'm going to have a minus y here. So now we've taken the greatest common factor out of each of our parts, our binomials. So once you've done this part, your inside should match. So they're both an x minus y. If they don't match, that's a really good sign you've done something wrong and you need to go back and fix it. These insides need to match. So now we're almost done. When we write our answer, what you're going to do is you're going to take one of the matching parts. So in this case, the x minus y. You're going to write one of those, and then you're going to take the part out front, the greatest common factors. Those are going to go inside their own binomial. So I'm going to have a 3 and a minus a, and that's your answer. So again, you're taking one of the matching parts, and then you're taking the two greatest common factors, and they're going to go in front, and you're done. So that's kind of the steps for doing factor by grouping, and that's why I like it with 4 terms more than 3, is because you're ready to go with just 2 groups of 2. So you take your group, take out the common factor, take your second group, take out the common factor, and then you're ready to kind of just rewrite your answer. So now I'm going to show you though how to do it with 3 terms instead of 4. So 3 terms is a little bit trickier because how can I group 2 groups of 2 if I only have 3 numbers? That's where these steps come in right here. So when you're doing your trinomial, first you want to make sure there's no common factor, and if there is, you want to factor it out. Then you're going to multiply the leading coefficient times the last number, so a times c. So let's just get up to that point for now. So first I'm going to see, are there any common factors? We have x squared, 3xy, and 28y squared. So looking at the numbers 1, 3, and 28, there's nothing in common there. These two have x's, but the third one doesn't, so I can't take an x out. These two both have y's, but the first one doesn't, so I can't take a y out either. So there's no common factors. We don't need to worry about that step 1. So step 2 was to take your leading coefficient, which if it's not written is a 1, and you're going to times it by the last number. So if I do 1 times negative 28, I just get negative 28. And then what you're going to do is you're going to think of what are 2 numbers that multiply to be negative 28 but add to be negative 3. So here's where it's really helpful to know your multiplication tables. If I think of my factors of 28, there's 1 in 28, but that's not going to add up to 3. There's 2 in 14, but also not going to add up to 3. Then there is 4 and 7. If I look at 4 and 7, can that be a 3? So yes, it would work. This is where you need to look at your signs. This is a minus 3. Right now I have both a positive 4 and a positive 7, but if I make this a negative 7, 4 subtract 7 is negative 3, which is what I'm looking for. Another way to do this step that I think can be helpful is you make an X diagram. And what you do with this X diagram is you're going to take this number that you multiplied, 1 times negative 28. So this negative 28 is going to go right here. And then the number that you're trying to get to, negative 3, you put on the bottom. So this is just kind of a visual way of organizing it. You don't have to do this, but some kids find it helpful. Now I'm trying to think, what are two numbers I'm going to put in these two spots that multiply to be this number but add to be -3? And so then we would do the 4 and the -7. So 4 times -7 is -28, but 4 subtract 7 is -3. So that's just kind of a quick way to organize it and make sure everything works out. So you're looking to see what multiplies to be the top part. I'll put a little X here, but adds to be the bottom part. And 4 and -7 do that. Okay, so that's kind of the first section for doing factor by grouping when you have 3 terms. Once you get these two numbers, what we're going to do is we're going to use these two numbers to, instead of have a -3xy, we're going to write it into two numbers. So I'm going to keep the first number, the 1x squared, and I'm going to keep the -28y squared. But instead of having that -3xy, we're going to break it into two pieces, the 4 and the 7. So we're going to have a 4, and make sure to bring down the xy, and we're going to have a -7xy. And since that 4 is positive, that'll be a plus. The reason we're doing that is because now instead of having 3 terms, we're breaking up this so that we have now 4 terms, so that I can do my 2 groups of 2. So then once you get to here, it's going to be exactly like this problem we just did. So you really, the 3 terms, you just have this extra setup to get to 4 terms. And then once you have 4 terms, it's going to work the same way as these problems up above. So we're going to look just at our first group and find the common factor. So for x squared and 4xy, there's no numbers we can do, but they both have at least one x. We can't take a y out because there's no y in this one, but we can take one x away from each. So I'm going to take an x away. If I take an x from x squared, I'm left with 1x. And if I take an x away from 4xy, I'm left with a 4 and a y. And then I move to the second group. Remember, if this first one is negative, we don't like that. I have a -7 here, so I know I'm going to take out a negative. And then if I look at my numbers, 7 and 28, we know that 7 goes into 28. So we're going to take out a -7. And then there's no x's on this second term, so we can't take an x out, but they both have at least one y, so we can take one y away. So now if we divide those, -7 divided by -7, those are just going to cancel. The y's are going to cancel. We just have one x left over. Moving to the second term, -28 divided by -7 is going to turn to a positive 4. 28 divided by 7 is 4. And then if I have 2 y's, if I take one y away, I'm left with 1 y. So once you have both parts finished, again, this is kind of your check. You want to make sure these two insides match. We have an x plus 4y and x plus 4y. That means we did it the right way. So now we're ready to write our answer. So to write your answer, you're going to take one of the matching parts, the x plus 4y, and then you're going to take the greatest common factors from the front of each one. Those are going to go inside their own group. So I'm going to have an x and then a -7y, and you're done. Okay, I know those are a little bit trickier because there's more steps. So if you need to, you can stop and rewind it and watch it again. And then I also have one more that we're going to do, so you can practice with this one as well. But if I look at this next one, again, we only have 3 terms. Our goal is to get 4 terms so that I can break it into 2 groups of 2. And that's why we have to do this little setup first. So we're going to see if we can get 4 terms by taking the first number and timesing it by the last number. So if I do 6 times -6 just equals a -36. And I'm going to think, what are 2 numbers that multiply to be -36 and add to be 5? So our factors of 36, I can do 1 times 36, but that doesn't work. We can do 2 and 18, but 2 and 18 aren't going to give me a 5. There's 3 times 12. 3 and 12, any combination won't give me 5 either. The other one is 4 and 9. Is there a combination of 4 and 9 that equals 5? And there is. So this is again where you need to think about your signs. This is a positive 5. So which one do I want to be negative so that I can get a positive 5? If I do 4 and negative 9, if I add those together, I get a negative 5. But if I do negative 4 and positive 9, that is going to equal 5. So that's going to be our pair right there. Negative 4 and positive 9. And again, you can do this little X table if that's helpful. I'll just write that really quick. The number you multiplied is in the top. The number you're trying to get to goes in the bottom. And then the two numbers you find go on the sides. So negative 4 and 9. Here's kind of just where you can check. Negative 4 times 9 is negative 36. So that works. Negative 4 plus 9 is 5. So that also works. So we know we're good. So this is when you take both of these numbers. And I'm going to write this out a little bit more than I did last time. I have 6x squared plus 5x minus 6. So remember, we started with 3 terms. We don't want that. The whole reason we did this entire section is to get 4 terms by breaking up this 5x into a negative 4 and a 9. So I'm going to do negative 4x and 9x. And it doesn't matter which order you put these in. I could flip this. I could put the 9x here and the minus 4x here. So it doesn't really matter as long as you have both of them. We're going to keep the first number, the 6x squared, and we're going to keep the last, the minus 6. So now we have 4 terms. So again, that's the whole reason we did this entire part, is we want to take the 3 terms and split it so that we have 4. Because now that I have 4 terms, I can do 2 groups of 2. And then we can do our factor by grouping. So now that we have our groups, I'm going to look at the first group and just take out the greatest common factor. So 6 and 4, I can take a 2 out. And then I have an x squared and an x. I can take at least one x away from each one. So remember, when I am doing the inside, it's really like I'm dividing it. If it helps to write it, you can actually write the division out. 6 divided by 2 is 3. X squared divided by x is 1x left over. And on this term, if I do negative 4 divided by 2, I get a negative 2. And then x divided by x just cancels, so it goes away. So we're done with that first group. Now we're going to move to the second group. I have a 9x and a minus 6. So again, we're looking for that greatest common factor, and then we're going to write the leftovers on the inside. So 9 and 6, I can take out a 3, but then this one has an x, but this one doesn't, so I can't take an x away. So we're just going to divide each of these by 3. So 9x divided by 3 is 3x, and 6 divided by 3 is 2. And make sure to bring that minus down. So again, once you're done with that, here's where you check. If these two insides match, that means you've done it right. So we're good. They're both a 3x minus 2. So now we're ready to just write our answer. You're going to take one of the matching parts, 3x minus 2, and then you're ready to take the greatest common factors from in front, and those go in the second set of parentheses. So 2x, and then because this is a positive 3, it's going to be a plus 3. And that's your answer. Okay. So that is how you do factor by grouping with 3 terms. Again, this whole setup right here is just so that we can take the 3 terms and turn it into 4 terms. And once we have those 4 terms, we're ready to do our grouping and we can get our answer.